This second stoichiometry problem that we can answer using a BCA chart is going to show us what happens if that first reactant is not the limiting reactant. So I start the same way. It's asking me how many grams of both products can be made from 100 grams of both of the reactants. So I just start out by putting in the original amount of each reactant. And I would start with no product, no moles of product, and I would need to convert both of these over to moles. So I just take my 100 grams of ammonia, right? 1 mole, 17.034 grams. So that means I would start with 5.8706 moles of ammonia. And I would start with my 100 grams of oxygen. And that would be 3.125. So I start with 3.125 moles of oxygen and 5.8706 moles of ammonia. Now, remember when we do the change, right, we assume that the first reactant is the limiting reactant, which means that it would all be used up. So if this went down by 5.8706 moles, then that would be all used up and we would have none left over. But let's see if we can do that. To find box number 4, which is how many moles of oxygen I would use, right? I use the balanced chemical equation to convert box 3 to the second reactant. So if I were to use up the 5.8706 moles of ammonia, how many moles of oxygen would I need? I use those coefficients from the balanced chemical equation. And when I do that, I get kind of a big number. I get 10.327. So now if this was going to go down by 10.27, what kind of number would box 7 be? Well, it'll be a negative number. I only have 3.125 moles of oxygen. I can't use 10.27 moles. So that means that I just decided that reactant 1 is that ammonia is not my limiting reactant. So now I know that the oxygen is my limiting reactant, which means this is going to be all used up, 3.125 moles of oxygen. And now I use that, now that I know that this is my limiting reactant, this is going to control all the other change boxes. So what I am going to do is come back, right? And it says that I need to go back and figure out, well, how much ammonia am I going to use when I use up all my 3.125 moles of oxygen, right? I will 7 moles of oxygen for every 4 moles of ammonia. And what number is that? It's going to be smaller, 1.7857. So this tells me that I'm going to go down by 1.7857 moles. And do that subtraction, and this tells me that I'm going to wind up with 4.08489 moles of ammonia left over. I'm going to have 0 moles of oxygen left over, 0 grams of oxygen left over. And now, in order to get box number 6, convert from moles to grams using the molar mass. So I know that I have, right, 4.08, 4.0849 moles of ammonia left over. And just converting that over to grams, I get 69.6 grams of ammonia left over. Therefore, that just is reiterating that ammonia is not my limiting reactant. But now I need to worry about all of these products, right? How do I get, like, for instance, box 9? Well, again, I use that highlighted. When I use up all my 3.125 moles of oxygen, I will use, or I will, create, what is this? 1.7857 moles of nitrogen dioxide. So this is 1.78517 moles of NO2. And how do I get box 10? Well, this is before I had 0. I've increased it by 1.78 moles. So I'm going to wind up with 1.78517 moles of nitrogen dioxide. And I would want to convert that number back to grams using the molar mass from the periodic table, 46.01, and that's going to give me 82.2 grams of nitrogen dioxide created. And now I just do the exact same thing for the other product. I know that I am going to use up all my limiting reactant, so 3.125 moles of oxygen, and according to the balanced chemical equation, when I use 7 moles of oxygen, I will produce 6 moles of water. This gives me that I will create 2.6785 moles of water, and since I start out with 0, I will wind up with 2.6785 moles of water. And I want to take that and convert it over to grams. And so this is going to be 48.3 grams of water. And now this should also prove or support the law of conservation of matter, right? Check to see, do the grams of matter before equal the grams of matter after? So before, I started out with 100 grams of each reactant. So I started out with 200 grams before. Now I have 69.6 grams of ammonia left over, and I have made 82.2 grams of nitrogen dioxide and 48.3 grams of water. And this equals 200, I think comes out to be 200.1 grams. And that's just because we had to round in certain places. That's why it's not exactly the same. But this shows us that I started with 200 grams, I ended with 200 grams. It wasn't 200 grams of product, it was that the product and excess reactant, leftover reactant, would weigh the same.